So thank you everyone for being here today and choosing the breakout room number 2. Today I'm going to present how agricultural policy information systems can be fed with in situ agricultural data derived from real parcels and that can address policy questions towards performance monitoring at a regional level. So let's begin. Today, I will present to you three main topics. We will begin by discussing the new Greek paying agency monitoring system. This system is used for compliance purposes. So we will discuss the system overview, the fundamentals that the system is based on, and its requirements. Then we are going to address an idea, a methodology of how you can combine in situ data with external data sources and with other heterogeneous data sources, and how those combined can offer additional value to policymakers. In the end of this session, I will present two tools that have been selected for demonstration to paying agencies and other authorities through the Tools4CAP project. The first one is the policy monitoring tool, and the second one is the aggregation dashboard. So we will have a brief demonstration to show you practical examples of how those tools can help answer policy questions. Now, starting with the new Greek paying agency monitoring system, its goal, of course, is to monitor agricultural activities and land use using satellite data and other digital tools for accurate, transparent, efficient, and timely assessment of farmer CAP declarations, and also monitoring not performance but compliance issues. That in the end, this information will be used to evaluate their ability to take financial support and utilize other CAP funds. Before continuing with more technical requirements, when a system like a compliance decision support system is designed, some fundamental practices or fundamental, very fundamental topics have to be considered, even in the design of the system. So the first one that is very important has to do with reusability of the data and how existing technologies like REST APIs enable platforms of member states, of other stakeholders, external databases to efficiently reuse data they already have. Of course, this will be enabled through the adoption of open standards and other data models in order to in order for those systems to communicate efficiently. The third one is the modular design, that when designing a software, essentially, stakeholders have to take into account that this is something that is continuously can be dynamic and can change from year to year, exactly like the legislation changes. Thresholds can change, methodologies can change, and additional features should be added. For example, eco schemes didn't exist a few years ago, so new expansions on existing systems have to be created, or a part of the legislation gets removed. So again, those systems have to be adapting to those dynamic conditions. Interoperability is the other main issue, as when external data sources are integrated into other solutions, there are various issues regarding the structure of the data and their specific properties. This is why a semantic data model, or to say it better, the translation of one database to another database have to be defined in order for the systems to be compatible. Other considerations have to do with the nature of the datasets, because we have different types of data that could be database registrations, it could be scanned documents, it could be online declarations, it could be of quantitative or qualitative nature. So in order to minimize human intervention into a complex system, data fusion techniques and other algorithms have to be considered from the beginning. Now, a brief overview of the system, which is comprised on 5 stages. So we can say that the new Greek paying agency DSS system is based on the area monitoring system already existing, or the traffic light system that most of the paying agencies across Europe utilize, or they utilize some variations of those. So the interesting part is that through these stages, I will explain to you that stage number 4 is the most interesting one. In the beginning, we have the data acquisition and pre-processing stage, which is essentially processing declarations and make the first evaluation, which is mostly eligibility checks. When those pre-checks have been processed, then the second stage, the satellite data processing, happens when homogeneity markers and specific satellite data are processed into variables per parcel, and in order to assess them individually and to correlate the activity captured by the satellite data with the declaration, the farmer declaration. When this decision engine gets activated, the outcome of this process is, for every parcel, we have 3 flags. So a parcel can have a green flag, which is this parcel is eligible and the data declared agree with the data from the satellite or other external data sources. It can be yellow flag. This means there is a partial agreement or an agreement that almost reaches a threshold, and there is a red flag where those parcels have an issue and they are marked as ineligible. Now, in the stage number 4, for the yellow parcels, the parcels flagged yellow, automated alerts are sent into the farmers, and they request from them to provide geotagged photos or farm calendar entries that and they can provide this information in order to reduce administrative burden and to mark their parcel from yellow to green. So this supplementary evidence review then is evaluated at automatically again at another stage, and we can say that this extra step essentially makes the process easier by integrating digital agricultural solutions such as tools such as geotag photos and farm calendar applications. So another interesting thing of the whole system is that it was produced in the NIVA project. So this is a good example of a European funded project that actually was adopted by a PEN agency, and methodologies produced in such initiative are utilized for the needs of an organization. In order to break down the requirements, we can focus on the next slide. We can focus on the step number 0, where there is a training and extraction of results from Earth observation classification engines. For example, the Tools4CAP system, which is a registered external system, is feeding data with the use of parcels and geometries from declarations into a decision engine. So this decision engine, as we said earlier, evaluates the declarations on 3 different outcomes. The yellow outcomes are then, in order to be marked as green, registered FMIS, Farm Management Information System providers can be connected in this system, and also farmers can provide the geotagged photos with a registered authorized application in order to continue with the evaluation, and in the end export the results through an API to even other services. So important components that we can say that important components of the architecture is the information sources registry, where a variety of heterogeneous systems have to be integrated to support and facilitate all this workflow. Data brokers that have to be implemented in various import and export data stages. Security and access control to ensure confidentiality. the decision engine, which can be adapted into the needs of different paying agencies. So specific thresholds can be calibrated or customized according to the specific regional or member state needs. Algorithms for decision-making processes are also essential in the process, as this is the engine of the workflow, and the front end that offers a user-friendly interface to technical personnel, policymakers, or officials is critical. When designing a front end, we have also to take into consideration the end users. So a different outcome, maybe an automated PDF report, could be more suitable for a high-end policymaker. A more detailed and analytic report or specific graphs are more useful to technical users of the application or the software. Now I presented you a system that is focusing on compliance, but in the Tools4CAP project, we want to also utilize existing on-farm data sources, except from geotagged photos or digital farm books, and include other systems, sensors, and management applications, and combine them with external data sources to have also a more sustainable and a more knowledgeable situation on specific regional performance. So how to address this is a difficult question, because essentially this is a question of the CAP transitioned from CMEF, compliance monitoring and evaluation framework, into a more performance monitoring evaluation framework. And there are different challenges that we had the chance to address in the Tools4CAP project also. So the main challenge was interoperability, because we saw that when data acquired off the farm, accessibility and the lack of standard data models become main challenges. Also, interoperability between existing administrative databases within the member state is also something that cannot be taken for granted. So, having identified those issues, the question on how to combine those two data sources, external data sources and on-parcel technologies. So we also try to identify the spatial and the temporal scale of the solutions to address more efficiently the problem. We can see that, for example, farm machinery data can be transmitted at a daily or even at an hourly rate. The frequency of updating a system is very high, while other indicators or other databases at the national level are updated at an annual level. So, as an example, this is one of the challenges that we have to address. This is why we proposing a landscape monitoring framework when existing farm-level technologies and systems such as Ajax or for example, FADN, FSDN data can be combined with other external data repositories, for example, Eurostat or JRC, and define specific algorithms in order to have outputs at a regional level. So those outputs are of interest, are essentially policy questions. For example, what is the amount of pesticides applied in a specific region in a specific season? And this way, historical comparisons can be made, regional aggregations and thresholds can be created in order to monitor progress towards, for example, sustainability targets. Again, the most related, the most difficult challenges to address were the interoperability and data sharing mechanisms, because there are no parallel standards in the EU at this moment. So every member state and every organization essentially follows an approach that it's not easy to integrate into a unified system. So now I will present to you the two tools that we will also present to European paying agencies in the context of the Tools4CAP project, and that try to address a more evidence-based decision-making that at a regional level again. So we'll begin now. Allow me to share my screen, and so I can demonstrate to you. So I will demonstrate to you a practical. I will demonstrate to you how we reached this, so how we materialize this idea, and what the initial data, what are our initial data, and how we can utilize it in order to produce regional aggregates. So we can see that typical pharma management information system dashboard, where a specific parcel has a specific crop, and some variables are available for this parcel. So let's make a search and essentially ask for a specific date period, what are the metrics, what are the data that this parcel has acquired in this period. It seems there is a technical problem. So in the first tool, so allow me to show you the second tool. So the second tool I would like to show you is the QuantiFarm policy monitoring tool. It's part of the QuantiFarm toolkit, and it is accessible to everyone. So in this tool, we exactly try to materialize this landscape monitoring framework. It's a work in progress, and we try to merge anonymized and aggregated in situ information from real parcels in the European Union, and to combine it with other farm calendar exports and other Earth observation data products to compute indicators at the regional level. So a user can select specific regions and at the local administrative unit level, and select a specific season and a specific crop. So by making this selection, we can see that the dashboard is updated with relevant information. Land cover distribution is also calculated, meaning that the policymaker can see that in the specific region, 13% of the area is covered by crops. And also another important information that can see is that which percentage of the area is protected under the Birds Directive or under the Habitats Directive. So we thought this is important information because it's important to know that 99% of the crop type area in this region, for example, is protected under the Habitats Directive. So this gives an overview and context to the official or to the person in charge, and to know the area better, to know the region better. And then we can move on into data that derive from actual parcels, and we can see the agrochemicals used for the specific season. So we can make assumptions based on Earth observation crop type data sets and aggregating regional usage of nitrogen into the whole region. So for as an example, we can see that if all farmers in this cultivating potato in a specific year in this region were applying a digital agriculture solution in their parcel, they would have applied 54,000 kilograms of nitrogen, while if farmers did not use digital agriculture solutions, they apply 39,000 kilograms of nitrogen. So this is also an important tool to show that how the digital agriculture solutions are better compared to other farmers that do not use digital agriculture solutions. Another example is the water consumption. So, for example, this is this specific example. We can see that water consumption is almost 20% less to users that utilize a digital agricultural solution than those that do not. So we can see that we can also calculate the benefit of a whole region, the regional benefit of real agro-environmental variables at a regional level by utilizing in situ farm level data. And that shows our first approach on how to apply the landscape monitoring framework we propose in the project. To sum up, it is important to have these kind of tools because we can answer this way. We can answer questions on how the region align with specific CAP goals and how specific regions compare to other regions, and what are the trends, which is important to know trends, especially when there are thresholds and goals, for example, the EU Green Deal goals, that a region has to take into consideration when creating policy. So I would like to thank you for today, and see you soon.